In this example, we're going to find the volume of a solid in the first quadrant generated by rotating around the line of x equals 2, and we're going to be bounded by these two equations. So let's create ourselves some sort of a visual for this. X values. So this graph right here is going to be a square root graph, which is going to kind of have this shape, and a parabola is going to have this shape. They're going to equal each other at 1. They're both going to start at the exact same y-intercept because they were both shifted up 1. And if I plug a 1 in here and I plug a 1 in here, you're going to get a 2 out of both of them. And so they're going to intersect at that point right there. And so our square root graph is going to have that shape to it, and our parabola is going to have that shape to it. Okay, and so we are rotating, though, around this x equals 2 line. All right, and so we are rotating around not a horizontal. So if we look back at this last one, we had the exact same two types of situations, and we were rotating it around the line y equals -1. And so we're rotating it around this way. We can leave everything in terms of y. But once we go to a vertical, now we're talking about everything in terms of, everything in terms of x's. This one's going to be, everything is going to need to be in terms of y's. So need in terms of y. Okay, so let's do a little bit of a tweak, and then we can kind of talk about what our setup is, because we have a washer that we have going on. And so we're going to be looking to do this pi big R squared minus little r squared to kind of find the volume of the big radius, and then we're going to subtract out the little radius. So we got to figure out what those are. So first thing, though, is we need everything in terms of r, in terms of y values, not x values. So our equations right now are in terms of x's. We need to adjust them. So if I take this equation right here, let's go down here, and I have my y equals a square root of x plus 1. Let's isolate the x instead. So we'll subtract the 1, y minus 1 equals the square root of x. We'll square both sides. So your x, or x would be y minus 1 squared. So that's the square root graph has an equation of y minus 1 squared. And actually, that's going to be part of the big radius. All right, because we're hitting that line. And then this shorter one is going to be the other equation, taking the parabola. And so y equals x squared plus 1. We'll subtract 1, equaling x squared and square root. And so we're looking at x equaling the square root of y minus 1. And that is this line. Square root of y minus 1. Okay, so to find this length right here, the whole thing is 2. So big R equals 2, but then we need to subtract out that little bit. And that little bit is based on that equation. So we're going to be subtracting out y minus 1 squared. Okay, so that's going to be big R. So to do our volume is going to be 2 minus y minus 1 squared squared. So there's our big radius squared. Minus our little radius is originally the same concept. It's 2, but we're going to be subtracting out more, making it a smaller radius. So that smaller, that distance is going to be based on this equation. So we're going to be subtracting out the square root of y minus 1. All right, so we'll go back up here. So that's big R subtracting out small r squared dy. All right, and then our bounds. Our bounds are y values, not x values. And so our bounds are going from here to here is what we got going on. So we're going from a 1 to a 2. All right. So let's this problem is one that we're going to do with the calculator. We're going to plug it right into the calculator. We're not going to go through all the math on it. That'll be for a different kind of a video. So we're going to take this value, kind of gets a little trickier than what we would like it to be. So we're going to turn this one into a calculator problem, and we're going to do the integral here. So we're going to go, integral from 1 to 2. And we got to be careful with all of our parentheses and everything. So we're going to have pi times, but we're going to need another set of parentheses because you're going to be multiplying pi. Well, in fact, let's do this. Let's just do the pi on the outside. And we don't have to worry about as many parentheses. So we're going to go 1 to 2. We're going to do our first big R. So 2 minus, we'll have to do it in x's, minus 1. And then that piece is squared. And then that parenthesis is squared. So we have, that's the big R being squared, but then we just happen to have another square piece within it. And then minus parenthesis 2 minus the square root, a variable minus 1. Let's get out of that. And then let's close that parenthesis. Squared. All right, so then that parenthesis closing that parenthesis, that's our little radius squared, and we should have that value. So that ends up being our volume for this one. So sometimes, most of the time, these are meant to be by hand. Every once in a while, they get tricky. And so we'll throw it into a calculator to get the answer. So 3.246 is our volume. All right, and so that was us doing a volume of rotating around a vertical line, which means everything needs to be in terms of y versus doing things in terms of x's.